Hey guys, so in this video I'm going to take you through a quick or kind of brief review of the forms that we've learned about quadratics and just kind of why we care about knowing them, what kind of important information they give us. And we'll just go one at a time. So the three main forms that we've learned are standard form, factored form, and vertex form. So standard form is the one that just looks like ax squared plus bx plus c, where a, b, and c are number coefficients. And this form is generally given to you. So how do we find standard form? Well, it's generally given to you. If you are given factored form or vertex form, you can multiply those out to find standard form. But this one is generally given to you, so you don't have to do anything. Okay, so why do we care about standard form? What's important about it? Well, the cool thing about standard form is that, if you were to plug in x equals 0, you would actually find the y-intercept is equal to c. So you'd plug in x equals 0 to find that the c value is the y-intercept. And so I want to show you in just a quick little example what that actually does, how that looks. So let's say we were given a quadratic in standard form like this. The cool thing about it is that when we plug in 0 for x, 0 squared minus 5 times 0 plus 2, well, essentially anything with an x next to it becomes a 0. And so I'm left with 0 minus 0 plus 2, which is just 2. And so that tells me that my y-intercept is 0, 2. Okay, so that's why we really care about standard form. It's generally given. You can find your y-intercept in a snap. Okay, so now let's talk about factored form. As the name implies, factored form is found by factoring. So you'd want to factor using like your box and diamond method. And then you could put an equation from standard form into factored form using that method. Okay, so why do we care about that? Well, if you recall, when you set your factored form equals 0, so essentially you're going to plug in y equals 0, you can find your x-intercepts. And you also need to use the zero product property to do that. And I wrote down here in the notes portion below what that is. So let's say we had some kind of example like y equals 3 times x minus 2 and x plus 4. So this is clearly already in factored form. And the zero product property tells us that either x minus 2 must be equal to 0, or possibly x plus 4 equals 0. And again, this is after plugging in 0 here because we're plugging in y equals 0. And I would find that my x-intercepts happen at 2 and negative 4. And so I get the points 2, 0 and negative 4, 0. So again, factored form is just really powerful because we can pretty quickly see what our x-intercepts are. Okay, so the last form that we got familiar with was vertex form. And we put an equation into vertex form by completing the square. It's that very nice area tile type of skill that we have. So completing the square. Vertex form, of course, as the name implies, tells us the vertex, which comes from h comma k. So in our equation over here where I see x minus h, notice that the vertex would be the positive h. So essentially you just keep seeing this h value kind of switch sign. If you see x minus 3, then positive 3 is the x value here for the h, right? If you were to see like x plus 2, then negative 2 would be your h value. K doesn't do that. K doesn't switch. It just stays whatever it is and it goes down. Okay, so let's say, for example, I had an equation that looked something like, I don't know, 2 times x plus 5 squared minus 3. I can see that this is now positive So the h value would be the opposite. It's going to be -5, and k would just be the -3 there. Okay, so I put on a couple of other reference things just to remember as you go through this unit. Here's your quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. And then your zero product property, which I referenced earlier, is just that idea that if two numbers are multiplied and equal 0, then either one number equals 0, possibly the other, or even maybe both.